Hello, this is a review for the Chapter 4 test that's coming up for pre-algebra, okay? So I'm just gonna go over some problems from a practice test that can be found in your textbook on page 215, okay guys? So I'm gonna go ahead and share my screen with you. Okay, so like I said, this is a pre-algebra review for the Chapter 4 test. And again, this is a practice test on page 215 of your textbook, okay? All right, so first I just wanted to point out a couple of things in the textbook. There are some key concepts. Make sure you're paying attention to those, either writing them down or at least reading through them and making note of them. So please make sure when you're using the distributive property, this one's all about the distributive property, you multiply a sum or difference by a number, okay? You're multiplying each term inside the parentheses by the number outside the parentheses, okay? So I just want to bring your attention to the word each, because I noticed that a lot of students multiply the term outside the parentheses by the first term, but they're forgetting to multiply by the second term, okay? And also it's important to pay attention if you're adding or subtracting something, okay? All right, so let's go ahead and continue. All right, so this is, I'm just going to jump through different problems, okay? I'm not necessarily going to do every single problem on the practice test, okay? So this one here says to use the distributive property to write each expression as an equivalent algebraic expression. So again, this term outside, you're multiplying by both terms inside, okay? So 9 times a, that's 9a. We don't know what a is, so we can't multiply 9 times a. And then 9 times, this is minus 4. So we end up with, we're going to be subtracting something, right? 9 times 4 is 36, okay? All right, so let's look at problem number 3. Another problem using the distributive property, okay? So now notice this number is negative, okay? So negative 5 times 3, that's going to give us negative 15. And then negative 5 times minus b, okay? Well, negative times negative is going to be positive, okay? And negative 5 times b, that is 5b, okay? If you would have multiplied negative 5 times 3 and got negative 15, and then you would have put minus, and then negative 5 times b is negative 5b, you would have ended up something like this, which you can simplify, okay? Remember, when you are subtracting, you add the opposite, okay? So this would become negative 15 plus positive 5b. So either way, you get the same simplified solution there, okay? All right, so we're going to move on to problem number 5, a word problem, everyone's favorite. It says, suppose you pay $15 per hour to go horseback riding. You ride 2 hours today and plan to ride 4 more hours this weekend. Write 2 different expressions to find the total cost of horseback riding. Okay, so first thing you can do is say, okay, it's $15 per hour, right? And the first day you ride 2 hours. Okay, so you're going to multiply 15 times 2, and then you go for 4 more hours over the weekend. So again, you're going to multiply 15 times 4 this time. So another way you can write this expression is that you're going to multiply 15 times 2 plus 4. Okay? All right. And then you're also supposed to find the total cost. So when you do that, up here, this ends up being 30 plus 60. Okay? And 30 plus 60 is 90. Okay? All right. Oh, that was part B. Okay? All right. Let's move on to to the next problem here. Number 7 says to simplify each expression, okay? So now we have this expression. This is not an equation because we do not have an equal sign, right? We cannot solve this. We're not trying to solve for x. We're being asked to simplify the expression, okay? So first thing we need to do is to combine like terms, okay? So I see plus 6x and I see plus 7x, okay? So if I have 6 x's and I add 7 more x's, that is 13 x's, okay? And then I have 10 minus 11, okay? So 10 minus 11, that's going to be negative 1, okay? 11 is bigger than 10, so we're going to go into the negatives. 10 minus 11 is negative 1. So my simplified expression is 13x minus 1, okay? All right, let's look at another one of those. Number 9. So again, we're going to only simplify the expression, okay? We're not going to actually solve. We cannot. There is no equal sign, okay? All right, so first thing that I see is the distributive property. So I need to distribute this negative 5, okay, to both b and to negative 4, okay? So nothing happens to that negative 7b. Negative 5 times b is negative 5b, and negative 5 times negative 4, okay, is going to be positive 20. Remember, negative times negative is positive. So now I have negative 7b minus 5b, okay? So I'm subtracting, right? So when I subtract, I add the opposite. So I end up with negative 7 plus negative 5. These are like terms, okay? So I can combine them. So negative 7 plus negative 5, that is negative 12, and I still have the b, plus 20, okay? So that's it. These are not like terms, okay? So that is as far as I can go, okay? So that is my final answer. Okay, number 10 says Omar and Deb each have a digital music player. I don't know if you guys remember these, like an iPod or something. Deb has 37 more songs on her player than Omar has on his player. Write an expression in simplest form that represents the total number of songs for both players. Okay, so we know that Omar will say that he has M number of songs. Okay, well, it says Deb has 37 more songs than Omar. Okay, so we would add 37 plus the number of songs that Omar has. Okay, so M is the number of songs Omar has, and then 37 plus M is the number of songs that Deb has. Okay, now it says to write an expression in simplest form. So notice we have like terms here. We have M plus M. So remember, there is a 1. If there's no number in front of a variable, there is a 1. Okay, so 1M plus 1M is 2M's. Okay, and then we still have the plus 37. We cannot combine those because those are not like terms. Okay, so that's it. And then number 11, another word problem here. So we have this table of information. These are the prices of different items at a snack bar. And it says, after buying some items, you receive $3.75 in change. If you paid with a $10 bill, which equation could not be used to determine the amount of money you spent? Okay, so N is representing the amount of money that you spent. Okay, so let's look at each equation. So this is saying if you take the amount of your change and add the amount of money you spent, then it should equal $10. Well, that's right? Because you paid with a $10 bill. Okay, if you add your change and the total you spent, you should get a $10 total. And then let's look at B. So this, since this can be used, this is not the answer. Okay, it's because it could not be used. to determine the amount of money you spent. So here we have $10, okay, minus the amount of money you spent is $3.75. Exactly, okay? So this can be used, okay, to determine the amount of money you spent. So we cross that equation out. And then over here, we have $10, the $10 bill you had, minus the change would give you the amount of money you spent. Well, that is also correct, okay? So we cross that out. This one says take the $10 bill you had, add how much you spent, and then you should get $3.75. Well, that's not possible, right? You can't add how much money you spent and then end up getting more than what you started with, right? Well, it'll be negative, but you can't spend a negative amount of money, right? So this one here is going to be an equation that we could not use to determine the amount of money we spent, okay? All right, so now the next section is about equations, okay? So there's a couple of properties that are discussed. This one is on page 186 of your textbook, okay? And this one talks about the addition property. And it says here, if you add the same number to each side of an equation, the two sides remain equal, okay? So remember, when you're dealing with equations, you can add, you can subtract, you can multiply, divide, but you have to do it to both sides of your equation. You have to keep it balanced, okay? So I'll give you an example here. If you say 4 is equal to 4, well, if I add 9 to 4, I get 13, but I also have to add 9 to the other side of my equation, or my equal sign, okay? And then they still end up equal to each other. 13 is equal to 13. So we have to keep it balanced. So it just gives you an example of the equation here. We add 5 to both sides, and we end up getting y is equal to 15, okay? All right, same thing with subtracting. If we subtract a number from both sides of an equation, it does not, as long as we do it to both sides, it keeps the equation equal, okay? So let's look at a couple of those. Okay, number 12 says a minus negative 12 is equal to 6, okay? So first thing I notice is subtraction here, okay? You guys need to get into the habit of every time you're subtracting and dealing with negatives, you want to change subtraction to addition, and to the second integer to its opposite, okay? So this becomes a plus the opposite of negative 12 is positive 12, okay? And it still is equal to 6, okay? So now I have, I'm adding here, right? So remember, you're always doing the inverse operation. So if it says to add 12, you are going to subtract 12 from both sides of your equation. So this 12 minus 12 is 0. So we end up with a equals, and then 6 minus 12, that is negative 6, negative 6, okay? And it says to check your solution. All right, it is a good idea to check your answers to make 100% sure your answer is correct. So if we put negative 6 in for A minus negative 12, we should get 6. Okay, so again, I'm going to add the opposite here. So this becomes negative 6 plus positive 12. Okay, and if I have 6 negatives and I add 12 positives, I end up with positive 6. So 6 is equal to 6, so I know 100% I am correct. Okay, so it might be a good idea for your test to take a couple, maybe another extra minute to check your answer to make sure you have the correct solution. Okay. All right, so let's look at number 15. Here we have negative b minus 15 equals negative 21. So again, we're doing the inverse. It says to subtract 15. So we're going to do the inverse and add 15. And the whole point of solving an equation is to get the variable all by itself. So everything around the variable we want to get rid of, okay? Starting with what's farthest away. So here we have this negative 15 plus 15, that's going to be 0, right? So we have negative b. Don't forget that negative, okay? And then negative 21 plus 15 is negative 6, okay? Now we don't want to know what negative b is. We want to know what b is. So we need to get rid of this negative, okay? So this, remember there is a 1 in front of a variable when it's all by itself. So there's a negative 1 in front of b. So I'm going to divide both sides by -1. So negative divided by negative is positive. So I'm left with positive b, and -6 divided by -1 is positive 6. Okay? Okay, so you remember you do not want to find negative b, you want to find positive b. Okay? Guaranteed on the test. If this problem was on the test, -6 would be a solution. So make sure you are mindful of those negatives. Okay? All right, number 17 has a fraction in it, okay? Still doesn't change how we do the problem, okay? So right now we have this 7/9. We want to get rid of 7/9. So since it's positive 7/9, we would subtract 7/9, okay? And we do that from both sides of our equation. If we had 7/9 and we subtracted 7/9, we're left with 0, okay? So we still have this negative or minus d. We cannot forget about that minus in front, okay? So over here, we are subtracting fractions, okay? So they have different denominators. We need them to have common denominators. Well, luckily, 9 is a multiple of 3 because 3 times 3 is 9. So we do 1 times 3, that's 3. So now we have 3/9 minus 7/9, okay? Well, that's going to be negative, right? 3 minus 7, that's -4. And then our denominator is 9, stays the same. So -4/9. So again, this problem we have this negative in front of d. We want positive d. So we were dividing by -1, okay? So d is equal to positive 4/9, okay? All right, next problem. This on page 193 of your textbook, it talks about the division property. You can divide something or divide an equation by the same number on both sides, and it will keep your equation balanced. Okay. Same thing with multiplying. You can multiply both sides of an equation by something, right? And you'll still keep your equation balanced. Okay. All right. So let's look at number 22. So here we have this negative m over 12, okay? So this negative either needs to go to the m or to the 12, okay? I recommend you move it to the 12, okay? And I say move it because it only goes to one, either the numerator or the denominator. If you put negative m over -12, now that becomes positive, okay? So only one of them can be negative. Now, I recommend negative because we don't want to find negative m. That's just an extra step, okay? So I would rewrite this as m over -12 is equal to 3/5, okay? So here, m is being divided by -12, so we want to do the inverse or the opposite operation, and we're going to multiply both sides of this equation by -12, okay? So that would cancel this out, and we end up with m, and then we have 3/5 times -12 over 1. And when you multiply fractions, you just multiply straight across. So 3 times -12 is -36, and 5 times 1 is 5. Okay? So this is an improper fraction. We can rewrite it as a mixed number. 5 goes into 36. 5 goes into 36. Sorry. See? Okay, sorry. So 5 goes into 36 7 times, and that's 35, and you have a remainder of 1. So it's 1 over 5. Okay, so that is equal to -7 and 1/5. Okay. All right. Now let's look at number 23. So here, d is being multiplied by 4/10. So we're going to do the inverse, and we're going to divide both sides of our equation by 4/10. So we have to see how many times 4/10 goes into 3 6/10. Okay. So we have to move our decimal point here over to the right. If we move this decimal over once, then we have to move this decimal over once. So that means our decimal is here. Okay. So then 4 cannot go into 3, but 4 can go into 36 9 times, and 4 times 9 is 36. Okay, so D is equal to 9, and there was no negatives to worry about in this problem, so D is just 9. Okay, all right, so here we have a word problem. It says approximately 1/7 of the people in the United States are left-handed. The population of the United States is about 300 million. Write and solve an equation to estimate how many people in the United States are left-handed. Okay, so our equation, the number of left-handed people is equal to 1/7 of the population. So of would be multiplication. So we're multiplying 1/7 times the population of the United States. Okay, so there's our equation. The number of left-handed people is equal to 1/7 times the population. Okay, and it says to write an equation and also solve. Okay, so we want to find out the number of left-handed people. It told us in the problem that there are 300 million people in the United States. So we're multiplying, instead of P, we replace that with 300 million. Okay. And then when we multiply 1/7 times 300 million, we end up getting 43 million. Okay. Okay. All right, so let's go on to the next problem. Okay, problem number 26 says to use the table to write and solve an equation to find each quantity. And here it's asking us the number of quarts in 16 pints. Okay, so we know here in our table, 1 quart is equal to 2 pints. Okay, and we want to know two quarts. So basically here, if 1 quart is equal to 2 pints, I want to know 16 pints, right? I want to know how many quarts, okay, are in 16 pints. So if I cross multiply here, okay, that's out of a proportion here. So I end up with 16 equals 2 quarts. Multiply 16 times 1 and 2 times q. Then I divide both sides by 2. I get 8 equals q. So there are 8 quarts in 16 ounces. Okay. Okay, next problem, number 27. So here it's asking for the number of cups in 2 gallons. Okay, now it doesn't tell us in this table how many cups are in a gallon, but it does tell us that there are 2 cups in a pint, and there's 2 pints in a quart. So in a quart, that means there are 4 cups, right? Okay, because there's in 1 pint, there's 2 cups. So if you have 2 pints, that's 4 cups. And then, so that means 1 quart is equal to 4 cups. Okay, 1 quart equals 4 cups. And then 1 gallon has 4 quarts. Well, if 1 quart has 4 cups and there are 4 quarts in a gallon, that means 1 gallon is equal to 16 cups. Okay. Now, if we say, okay, well, 1 gallon is 16 cups, we set up our proportion, we want to know 2 gallons is equal to how many cups, okay? So we multiply 1 times C, so that's C, 1C, and then 16 times 2 is going to be 32. So there are 32 cups in 2 gallons, okay? All right, and then Number 29 says we have a two-step equation here. Okay, so now we're going to be adding and subtracting something from both sides and multiplying or dividing something from both sides of the equation. Okay, so first I need to get rid of this -4, so I'm going to add 4 to both sides. 28 plus 4 is 32. Okay, and I have 4g, and then this -4 is 0. So now I have a one-step equation. So g is being multiplied by 4, so I do the inverse and divide both sides by 4 and get 8 equals g. Okay. All right, just a few more. So here's another two-step equation. So first, I want to get rid of this 211. So I'm going to subtract 211 for both sides. And this ends up being 0, and this is negative k over 3 equals negative 111 minus 211 is negative 100. Okay, so now I'm going to multiply both sides of this equation by -3. Okay, I want to get rid of this negative over here. So I multiply the negative 100 times -3 as well. So these are cancel out, and we get k equals negative times negative is positive, and 100 times 3 is 300. So k is equal to 300. All right, and then number 32 says Mr. Carter is renting a car from an agency that charges $20 per day plus 15 cents per mile. He has a budget of $80 per day. Write and solve an equation to find the maximum number of miles he can drive each day. Okay, so he's paying $20 a day plus 15 cents per mile. Okay, that's going to give him, that gives him the total cost, right? We'll call that Y. Okay, well, it's telling us he has a budget of $80 per day. So for one day, so that's $20 plus 15 cents per mile. We want to set that equal to 80. So now we just have a two-step equation. Subtract 20 from both sides. You get 1500 times m equals 60. Then you divide both sides by 1500. And m is equal to 400 miles. Okay? All right. And then problem number 33, this will be the last one. It says Kenneth signed up to receive internet service for $13 per month plus a $30 startup fee. Which equation could be used to find the number of months he can receive internet for $134? Okay, so we need to look through each one of these equations and see which one describes the situation that's described up here. All right, so this says you take $134 plus 30, it's equal to $13 a month. Well, we want to know when the total is $134 a month. So this is not even set equal to 134. So that's definitely not our equation. Notice the remaining equations are all set up to $134, okay? So it's $13 a month, okay? So $13 a month plus 30, plus 30. So we'll just look to see which one of these matches that expression, okay? It's not $30 a month. It's not $30 minus $13 a month. That's not it. $13 plus $30 a month. That's not it either, right? It's only $13 per month. So one-time fee of $30, $13 a month for a total of $134. So it has to be J, okay? All right, well, thanks for watching. Hopefully this video was helpful in preparing you for the Chapter 4 test that's coming up. If you still have any questions, please either call me, text me, email me, or stop by my office hours, and I'll be happy to help. Okay, have a great day.